Hey, Wagwan. It's Mr. Garfield here, and I'm going to look at a CAPE integrated mathematics question, okay, from module 3, that is calculus, and I want to look at a limits question here. All right, so I created this question for you guys, and just to show you that, these types of questions can appear in your examination, right? Don't expect all the limits questions to look exactly the same. Okay, so here the question says you are to determine the values of k such that the limit of e to the 3x squared minus 12 as the x approaches k is equal to 1, where k is a member of a set of integers. All right, so let us do our solution here. So they told us that the limit is equal to 1. Now, first of all, how would you calculate this limit? All right, so we want the limit of e to the 3x squared minus 12 as x approaches k. All right. Yes, we don't know what is k, right? That k value is what we're trying to find, or values that we're trying to find, right? But how do you obtain this limit? Well, of course, you'd use direct substitution, right? Whenever we're doing limits, we know that we just substitute that k value inside of the function for x, right? So using direct substitution, I can say that this limit is going to be equal to e to the power, substituting x as k, I will get 3k squared minus 12. Okay, that is my answer. But how is this going to find the limit? How will this information help me to find the limit? Well, I can say since I know that the limit, right, since I know that the limit as x approaches k of e to the 3x squared minus 12 equals e to the power 3k squared minus 12. All right, so since I know that the limit is equal to e to the power of 3k squared minus 12, and I know that the limit of e to the 3x squared minus 12 as x approaches k is equal to 1, that's what they told us in the question, right? Then I can say what? So if the limit is e to the 3, if the limit is e to the 3k squared minus 12, and the limit is also 1, okay, then I can say that e to the 3k squared minus 12 is equal to 1, right? I hope that makes sense to you, okay? Because they told us that the output is 1, or the limit is 1, right? The value that we're approaching is 1. So, and I use my direct substitution and say that the limit is e to the 3k squared minus 12. So what I am saying here is that e to the 3k squared minus 12, whatever value that is, okay, whatever value that is, it must be equal to 1, okay? So e to the 3k squared minus 12 equals 1. How am I going to find k now? Well, you will have to use your knowledge of indices, okay? So you should note, let me just put some things here for you to note. All right, you should note that e to the power of 0 is equal to 1. All right, e to the power of 0 equals 1. So I can say e to the 3k squared minus 12 is going to be equal to 1 can be written as e to the power of 0. Okay, now what is the reason why I wrote 1 as e to the power of 0? Well, you should recall from the laws of indices that if I have a to the power of m being equal to a to the power of n, then it implies that the indices are equal. So m is equal to n, right? So whenever you have a to the m equals a to the n, meaning that you have the same bases on both sides of the equation here. The same base here is a, okay? Then you just equate the powers or equate the indices. So m equals n. Likewise, for this example, the same base here is e, right? E. Now, e is a number that you should be familiar with. Okay, that is what we call Euler's number, discovered by the Swiss mathematician Leonhard Euler. Okay, so is equal to 2.7182818284590 and so on. Okay, it is an irrational number. That number never ends. All right, that's what we call Euler's number. Okay, so if I know that e to the power of 3k squared minus 12 equals e to the power 0, and I can clearly see that I have the same bases here, e's here and e's here, so I can just equate the powers. All right, so the powers is 3k squared minus 12 is going to be equal to 0. All right, so I equate the powers. Great. I just now find the value of k. So I'm going to carry the negative 12 on the right hand side of the equation by adding 12 to both sides of the equation. So if I add 12 to both sides of the equation, I will get 3k squared on the left hand side, and that is going to be equal to 0 plus 12, which is 12. All right. Now I have 3k squared on the left hand side. I don't want that 3 there. So to get rid of the 3, I'm going to divide both sides of the equation by 3. And if I do that, I will get k squared on the left hand side. And on the right hand side, I will get 12 divided by 3. Okay? So I have k squared equals 12 divided by 3. K squared is now going to be equal to 12 divided by 3 is 4. All right, so I have k squared equals 4. I want the value of k, so I need to get rid of this square here. All right, this square here, I need to get rid of this 4. So I'm going to get rid of it by applying the square root to both sides of the equation. Okay, so when I take the square root of k squared, I will get k, and that is going to be equal to the square root of 4. All right, so I'm just applying the square root to both sides of the equation. Now you should know that whenever we take the square root of a number, it is going to be plus or minus in front. All right, so plus or minus the square root of 4. So k is going to be equal to plus or minus the square root of 4 is 2. So k is equal to plus or minus 2. All right, and that is my answer there. Okay, so what is that telling us here? This is telling us that if this value k is 2, all right, if the value of k is 2, then the limit is going to be equal to 1. Also, if the value is negative 2, if k is negative 2, then that limit is also going to be 1. All right, and they told us that where k is an integer. And of course, 1 and negative 1 are clearly integers, right? So we know that our answer is correct. Good. So to know if that, in order to know that you're correct for this question, just substitute k as 2, use direct substitution, all right, to find the limit. Use k as 2, you should get 1. And if you use k as negative 2, you should also get 1 as the limit. Okay, good. So I hope that this question was helpful for you. All right, if it was, please ensure to like of the video and subscribe to the channel. I am Mr. Garth Reed, student ambassador for the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.